This week, Micron Technology unveiled an exciting step forward for its DRAM innovation and the memory market with the shipping of its 1-beta DRAM process technology to the mobile ecosystem. Its 1-beta node, the world's most advanced DRAM technology, cements Micron as uniquely leading in both DRAM and NAND innovations. Daniel Newman and Patrick Moorhead spoke with Thy Tran, Micron's VP of DRAM Process Integration, to get the inside scoop on all the exciting innovations that went into this major milestone and what this means for the market.
Hi, this is Pat Moorhead with More Insights and Strategy, and we're here for another 6-5 Insider podcast. I am broadcasting from probably more than an undisclosed location, if you can look over my shoulder here on the West Coast, but I am joined by my amazing co-host, Daniel Newman, founder of Future Research. Daniel, how are you, my friend?
Hey, Pat, good morning. It's beautiful. It looks like our sky is continuous right now, almost the way it's setting up perfectly, because we are both on the West Coast, and it is good. I'm not where you are, and that's kind of rare because people get used to seeing you and I in the same place. But it's also one of those cases where we are all over the map right now. So many events, so much travel, but so much to be excited about. But I am really, Patrick, excited about this conversation today. This is going to be a good one.
No, absolutely. So without further ado, let's introduce Thy Tran. She's VP of DRAM Process Integration from Micron. T, happy announcement day. How are you doing?
I'm doing great. Thank you, Patrick and Daniel. Thanks for having me.
Yeah, absolutely. So Danny, let's jump right in.
Yeah, it's great. And I like that we are using it. We're being a little bit ambiguous right now. It's announcement day. What does that mean? Well, you know what, T, we brought you on the show. So what I will say is this, is you guys have made some really big progress over the last year. It's another big announcement, 1 beta. Let's unpack that. What is it? What does it mean for the market?
Well, it's incredibly exciting, and this 1 beta milestone is a huge one for Micron. It marks the second time that we're leading the industry in both DRAM and NAND. So we were conscious about how competitive the landscape is out there for DRAM, and we wanted to avoid being the one-hit wonder, and we wanted to have a steadfast, performance and our leadership so that we can maintain our industry leadership in the market.
Yeah, we've been covering your first to market, and those never get boring. But I'll admit, and I mentioned this to you in the green room, Micron was not as communicative as it was for a few years. And then I was wondering, hey, what's going on there? And then you come out this, hey, first to market with this in NAND, first in market with DRAM. And the latest one that we had talked about and that I'd written about was your first to market 232 layer NAND. And then, here we are, 1 alpha DRAM, 176 layer NAND. So the question is like the how, right? It's obviously you're doing it, but can you talk maybe a little bit about your innovations, your investment, in that you're able to get ahead of the competition like Samsung and Hynix?
Sure. I wanted to call out that it's interesting how you note that we used to be quieter or more stealth mode. And we were very careful to basically avoid announcing things that we cannot deliver. So we wanted to have, concrete achievements in hand before we make announcements.
Yes.
So with respect to innovation and how we're achieving that in both DRAM and NAND, our executive team have been quite aggressive, and our board also, in terms of enable us to invest in not only new tools, new equipment, but also in terms of our engineering and manufacturing facilities, our pathfinding team. And then also, if you look back some years ago, we were actually behind the competition, and in both DRAM and NAND. And so we surged ahead, and we led the competition in NAND. And then DRAM, we were struggling for quite some time. But along the way, we basically, instead of trying to play fast follower, we changed our mindset to, be try to lead instead of follow. And we have this this new way that we're working, and we innovate, and we're much more aggressive in terms of scoping out what is possible instead of trying to follow the pack.
Yeah, I always like quiet and effective, in my opinion,
Mhm.
especially right now, kind of in this kind of difficult market space. We want to hear from companies that are getting it done. And so, as far as we're concerned, don't feel bad about being a little stealthy. That's okay. A lot of companies make a lot of noise, they're really loud, and then what they come out with doesn't necessarily, meet the innovation requirements. So you can kind of go both ways, and it seems you've picked that latter path, which is great. Talk a little bit more about the specifics of the and this has got to be your thing. I just, based on your title, this, we're getting right into your wheelhouse here. But when it comes to the innovation and the techniques that Micron is using and adding to achieve this one beta, so you went from one alpha to one beta. What did you do to really drive this innovation in the process?
So we we look at all aspects, multiple fronts. We initially scope out whether a process or a module or the entire flow is scalable to the next shrink. So we go about by first starting with the memory array. That's kind of like the holy grail. How aggressive can you shrink that? And traditionally that was where the focus was, and as we start hitting the scaling wall, or starting to hit the limits of physics, we had to look in other ways to be more creative, and push the other aspects of the die. So but most of the die, the chip that you have, is taken with the area by the memory cell array, and the rest of the circuitry, the sense amplifier, the word line driver, and the periphery devices, all the core logic and so on, before it was not keeping pace with the memory cell array shrink. So through collaboration with our technology team, from process integration to process engineering, and also design team and product engineering team, we collaborated in a holistic way. And so we scope out what is possible in terms of not only pushing from the process side, but enabling design and technology co-optimization. So we find the sweet spots for each, and everything is on the table. We don't just shrink the cell array, we shrink everywhere that's possible. So we challenge ourselves to be aggressive and make risk decisions by committing to something, betting on something with our engineering judgment, with our fundamental studies, and then pushing beyond what we think is possible in terms of multi-patterning technology. As you know, our competitors have forged ahead with EUV lithography, but our strategy has been you deploy it when you really need it, and it has to meet the performance of multi-patterning strategy and the cross point. So, and through our engineering prowess, our innovation prowess, we also were able to leverage between NAND and DRAM technology. So we borrow the initial pitch, or we call it pitch multiplication, but you can call it multi-patterning. And we leverage that for DRAM, and because DRAM capacitor has the most stringent requirements in terms of critical dimension uniformities, for example, and how we pattern that, we had to also innovate and advance that technique and process. So besides the traditional line space printing, we were able to advance our multi-patterning process for contact layers, for different layout configurations. And so additionally, besides the patterning, which is the first step, you got to make the features. We have to meet all of the electrical requirements, for example, resistance, capacitance, to meet the parasitic requirements, not only in the array, but also the rest of the die. So besides just focusing on the capacitor and how much capacitance we can get for refresh, and still meet the leakage requirements, and the other parameters like array timings, and whole row hammer type of mode that we have to protect the customers from. We basically have to engineer every single module. You know, capacitor used to be the most critical module. Now, like you look everywhere, everything is like hitting the limit of the scaling wall. So do you reduce your shrink, or do you, you know, push the limit, and then you find the sweet spot for each of those, you know, in terms of process design points and geometry design points, and you integrate that both with technology and design.
T, my mind is always blown when we have somebody intelligent and super smart and super experienced on the show. But my net from that is that you take a device approach, a couple things. First of all, you take a device approach versus the cell, right? You're not just looking at the cell and shrinking it. You're looking at the entire device and ways you can optimize for that. And the other thing you talked about is, Micron has a very robust memory and storage business, so NAND and DRAM, and you're able to leverage many of those learnings, particularly on the process technology improvements. And I'll bet there's some advantage on the design side to leverage that. So we've talked a little bit ethereally at a very kind of micronic level, get it? But hey, let's talk about the devices themselves. So you're first launching one beta on your mobile memory, LPDDR5X, and I'm curious, what are some of the benefits that you're most excited about with LPDDR5X and the mobile ecosystem?
So yes, the LPDDR5X, it's hard to say which I'm really most excited about, because we're reducing the power, by 15% on that front. And, from a sustainability standpoint, that is always good for our Earth. And I would say that the fact that we can hit the three corners, the density, memory density, capacity improvements, over 35%, the 15% in power reduction, and at top speed of 8.5 gigabits per second. And if you look at it as a whole, that triangle of hitting those three, we're able to achieve our cost point, which is one of the reason why we deployed next generation DRAM and NAND. So holistically, the technology one beta allows us to deploy the broadest product portfolio. So what I think I'm most excited about is not only particularly for DDR5X, but the ability for us to farm that out to all market segments, and that's quite powerful. I would say it's probably the technology, the node that is enabling the broadest product portfolio.
Yeah, and just a quick clarity question. When you say mobile, is that smartphone or smartphone and notebooks?
So mobile, it actually is both. But initially, the LPDDR5X, we're focused on the smartphone markets.
Excellent. Yeah, you gotta. Even though it's declined a tad, you're still looking at around a billion devices a year. So, no, that's incredible. And it's incredible that no matter how much technology comes down the line, I've never heard anybody who's like really excited and happy about their battery life. So, we keep increasing capability with CPU, GPU, NPU, ISPs, and we're creating all these energy sucking devices. And, everybody's trying to figure out, hey, how do I not hit memory all the time? Because it just drains the battery. But as you know, more memory is a better experience. So as opposed to going out to storage. So anyways, just wanted to get that clarification in.
Pat, it's funny because I'm still back in the LPDDR5X. Say it 5 times fast. When you guys were going back and forth, I really wanted to pause the pod and to have like a little bit of a lighter moment, because this is this stuff gets really technical, and you do a nice job of explaining it. You kind of I want to double click on something you talked a little bit about. You were talking about the challenges of DRAM scaling when you were kind of talking about the innovation. And just for everybody out there, to get to 1 beta was a lot of work. And so again, these technical terms, sometimes it gets lost. Like, yeah, more memory, yeah, lower power consumption, yeah. And I mean, this is like, and now with every chip company constantly kind of dumping their newest thing on the market, I think some of the great work gets lost in translation. So can you just give a little bit more kind of history, the challenges of DRAM scaling? Because you guys, this is something you're really uniquely doing that's gotten you into this unique position in the market.
Yes. So, if you look back some years ago, when you ask how to do DRAM scaling, it was capacitor, capacitor, capacitor. So in a DRAM cell, it's very simple. It's two basic elements, a capacitor and a transistor, right? And then we have billions of those. And, in terms of capacitor, that was our holy grail. But now, we have to focus on the access transistor, and not only that, but the connection, so how we connect the transistor to the capacitor, how we connect the transistor to what we call the word line, and then also the bit line, just to connect to the rest of the circuit. And then, as I noted earlier, besides that memory cell array, which we spent, most of our focus on, now we have to deploy, advanced CMOS technology. Now, our logic, industry has been at the forefront. And the reason behind that is they're not limited by what we call the thermal budget of the DRAM, flow, which is, basically temperature and time. And DRAM for the memory cell array integration requires very high thermal budget, so high, long time and high temperature. So not only do we have to take care of that basic fundamental transistor capacitor, we have to deal with the rest, and we push the envelope of CMOS technology innovations by leveraging the learning from logic, but also we have to innovate to integrate that with the rest of the flow so that the memory cell array has the best performance. And then the rest of the circuit, the sense amplifier, as I noted earlier, the local word line driver and the periphery circuits, have the optimized timing that allows you to basically reduce the power consumption. So basically just, dissipate less heat and give you longer battery lifetime, and also be as fast as we can. We all want our data, at our, at the snap of our finger. And as you noted earlier, that no one's happy with their battery life, right? You can never have enough battery life. So you can never have enough memory, but you can never have enough battery life either. So it's basically, we leave no stone unturned.
Yeah, again, another great explanation of something that is so difficult to get your head around. I mean, in the old days, we used to consider, hey, we're going to do a shrink and it's easy, right? But the fact is that, every 5 years we talk about how the industry has run out of gas. We can't shrink it anymore. But through the innovation of people like your team and Micron, you're able to do that. I'm still a little bit stuck, Daniel, on the LPDDR5X 5 times, but I did want to drill in, and this is a future statement. You talked a little bit about some other applications and what we could expect, but you're very much in any kind of device on the planet, whether it's a car, a server, a desktop PC, pretty much anything that requires some high-speed memory. So what benefits does this new process node 1 beta bring to the rest of your segments? I know you're not launching those yet, but I think the audience would like to hear what it brings to the table: performance, power, things like that.
It's absolutely all of the above. But I want to go back on the LPDDR5X. Easiest to say LP5X. So that's the short
Oh,
version of it.
come on, it's fun. Let's keep going.
Yeah, but with respect to the benefits, so the way that we develop the portfolio, it's not only to be robust for one product family, it has to, be able to meet the requirements for the broader market segments. And so the ability to, design it so that the process design point is most optimized. Not, it's may not be the sweetest spot for every single device, but
Right.
it's somewhere where it's optimal enough for where the entire process window can, facilitate all the requirements for the different products. We have uh, numerous other products planned, and quite a few are in the works already. So the requirements for example for graphics, in terms of even faster speed, right? And especially high bandwidth memory.
How did I forget about graphics? I did
Yeah,
though. Gosh
yeah,
darn
and
it.
as you know, we've led in graphics as well. Graphics, high bandwidth memories have very different requirements compared to low power, right? Because you can design the process design point to optimize more for speed instead of and it's more forgiving for power, and also for, especially for cost margins, right? So we can, the way that we designed it, you can add a little bit more bells and whistles from the process side to enhance that. So it's basically like a toolkit where you have all the tools and the knobs to tweak and turn so that you enhance for each individual product. So it's a base platform that is so robust that we're able to deliver that. So
I am,
that's really exciting.
I am seeing some power budgets on the latest graphics cards that are absolutely stunning. And by the way, we can say GDDR6 six times fast as well. No, sorry to cut you off, but you're right. The more power efficient you can be, for example, on a graphics card, the more power budget that you have to put in the processor. So
I think her examples of the knobs or the levers, right? There's always a bit of a give and take if you're, using a lot of power for one thing and how that impacts. I could use a little of that rendering and graphics to get this bright sun. It's so beautiful at the start of that, and then the exposure just comes through, and it's like, well, I guess if anybody's face in this group is going to get washed out, it should be mine. But in all serious, T, you took a really complicated topic, and I think you've made it digestible, and that's really what we like to focus on here on the 6.5 is, we love the semiconductor space. We love and know that the technology that is being built by companies like yours at Micron is changing the world, changing the dynamics of compute and what companies are able to do in the data center, on mobile, and of course, on our PCs. And I just want to thank you so much for joining us today, T, on the show. You're now an alumni of the 6.5, and we're going to have you back on really soon.
Yay. Thank you. Thank you, Patrick. Thank you, Daniel. So I just want to say, close, with this note, Micron, again, can maintain our leadership position in both DRAM and NAND. I mean, and for the past few years, working on the world's most advanced DRAM node was really a labor of love for our One Beta team. And, it's been an extraordinary engineering feat, one that we're super proud of. And so we look forward to sharing more memorable moments with you.
Well, congratulations again. Great news. We'll be sure to have this out. And everybody out there, check out the show notes. We'll have links to more information from Micron. And of course, this great conversation with T. For this episode, though, it's time to say goodbye. Hit that subscribe button. Join us here for all of our weekly 6.5 shows and our insider editions. We have a lot of great executives just like T that join the show week in and week out. And we appreciate everyone out there in our community. But like I said, time to say goodbye. Have a beautiful day, everyone. See you later.